And actually, I mean, if you look at this slide, I mean, to me, actually, the most scary number is the operational cost of 1.3 billion per year. So if you look at what is the annual budget of CERN, it's below that number. So, yeah, it looks very ambitious. And of course, I mean, we have a great physics case, yeah, but we have to go out as a community and convince the politicians, the society, other science fields that this is a worthy investment. I mean, it's not a no-brainer, and it needs real work, and it needs to convince other people, the other players in this game, that this deserves additional funding.
What's up, you scholars of enlightenment? Dr. Sam Gregson, particle physicist here again. I hope you've had a brilliant week and have a fantastic weekend in store. Now, today, we're going to be discussing a presentation that was made by the German Federal Ministry of Education and Research, and which has caused a little bit of a stir in the particle physics community. Germany is CERN's largest funder, and yet this presentation describes CERN's flagship Future Circular Collider, the successor to the Large Hadron Collider, as currently not affordable. Germany currently provides millions of euros of federal funding to CERN and is the single largest national contributor. What they choose to fund can have massive impacts on the viability of projects at CERN. Last week, a representative from the German ministry attended the Helmholtz Alliance Physics at the Terascale workshop in Bonn, Germany, and outlined the ministry's position on a future circular collider at CERN, and it was not particularly positive. The representative castigated CERN's financial planning for the FCC as extremely vague, and highlighted concerns that other partners would have to step up and support any enhanced financial contributions coming from Germany. The ministry representative, Dr. Eckhard Lilienthal, even went so far as to encourage CERN to explore future scenarios which do not include a future circular collider, and described CERN's flagship 100-kilometer-long machine as currently not affordable. To quote from Dr. Lilienthal's presentation on the affordability of the future circular collider, the cost estimates in the feasibility study are subject to a large number of uncertainties, the effect of which are still largely unknown. The financing plan is extremely vague and requires a high level of commitment from external partners, which is neither assured nor even in prospect at the present time. Under the current economic conditions, Germany is not in a position to provide the planned funding. In view of all these points, the FCC has to be considered as not affordable. Hence, CERN has to diversify its efforts and prepare for different scenarios, including one without the FCC EE. To help me dig into these potentially concerning statements and understand the nuance behind them, I'm joined by a phenomenal special guest, Dr. Christian Grefe. Dr. Grefe is a particle physicist at the University of Bonn, working on the LHC ATLAS experiment at CERN. His work focuses on ATLAS data quality and Higgs decays to leptons, including tau leptons. He was also present for the German ministry presentation and the associated discussion. So I couldn't hope for a better special guest to help me dig into this political wrangling around a future circular collider at CERN. Right then, so Christian, before we get into the German Federal Ministry of Education and Research and what they're currently saying about the future circular collider at CERN, which is that it's not affordable at the moment, let's start from the start. Why is CERN looking to build a 100-kilometer long future circular collider? What's the case from inside the field? What's the physics case for the FCC?
Yeah, it's really, since we have discovered the Higgs boson, right? We have discovered the last missing piece in the standard model. And then, of course, to the outsider, it might say, okay, now you're done, right? But actually, the journey only starts now, because we have found this new particle, which is really a new tool in our toolbox to understand nature, right? Yeah. So the Higgs has such a special place in the standard model because it couples to all the massive fermions, the gauge bosons, and so we have now measured one can say all the couplings to the 10% level, or maybe a bit better or a bit worse, depending on the individual values.
Yeah.
But then to really make sure, to really be able to say, yes, this is really the standard model like Higgs boson, or maybe something much more interesting, one has to understand this much better. And of course, we still have the LHC is running, we have the Hallume LHC coming up. We will measure it better, but to really fully understand it, we need an E plus E minus Higgs factory. And I think everybody, at least within the field, agrees with that statement. And it was made in the European strategy, the previous European strategy update, which was done 2021, I think. And this was made in SNOMAS and P5. And I think really everybody wants and thinks that the next big machine in the field should be a E plus E minus Higgs factory. And one of the options at CERN could be this FCC tunnel.
So when we talk about E plus E minus, we've obviously got a Hadron Collider at the moment with the Large Hadron Collider. So we're talking about E plus E minus because it's much cleaner, much easier to do precision measurements of the Higgs. Is that really the motivation?
So that's the one aspect, is that the event itself is much cleaner, right? You don't need triggering like we do at the LHC. You can really look at every single event. You have less pileup. The event is easier to reconstruct. But most importantly, the way that we produce the Higgs boson is very different, because when you collide fundamental particles like E plus E minus, then you know the initial state precisely, and that helps you to then infer more about the whole event that you're reconstructing. While on the other hand, in proton-proton, like, of course, the protons are colliding, but what's really colliding are the quarks or the gluons.
It's like throwing two bags of potatoes at each other, and you're getting different things every time.
So, and you don't really know, like statistically we know what's happening, but for every single individual event where you want to reconstruct some kinematics, you can only do this, with limitations. And so that limits you also in the interpretation. And E plus E minus has just very beautiful ways to understand the Higgs boson in a basically model independent way. You don't have to make assumptions about what the Higgs sector actually looks like, while when we interpret the results from the LHC, we always have to make some assumptions. When we say we measure cross sections, we actually only measure ratios of cross sections. So that gives some degrees of freedom that we cannot disentangle. And the E plus E minus collider would solve this, right? And we could also, in addition, have an absolute measurement of the total width, which would tell us, is there some hidden sector? Is there some invisible particles that the Higgs can decay to that we're just not seeing because, well, there's nothing to measure. But if you know the total width, you know basically the fraction of invisible decays, and that helps you, or that would tell you that there's some dark hidden sector that the Higgs is coupling to.
So just for those who are watching who might not kind of quite understand that, I think Christina, correct me if I'm wrong, but about 10% of Higgs decays we aren't sure where they go. So
this is the current limits. This is the limits that we can set, which of course is already great, right? We know, but by basically looking, how often do we see basically events that have no signature except for some recoiling objects, and then we say, okay, this is the limit on invisible Higgs decays. But 10% is not sufficient to that's the upper limit, right? So we don't know, and well, the real invisible fraction, like in the standard model, there are some invisible Higgs decays that we know of. Like if the Higgs decays to two Z bosons, the Z bosons can decay to neutrinos. These are the only ones we expect, but that's a much smaller fraction than 10%.
Yeah, so there's a lot of places in there for new physics to be hiding. So we want to be studying the Higgs in detail, its couplings. We want to be looking at its width. We really want to be nailing down this new probe of the universe that we've just found, and we can do that in a cleaner experiment and do that in E plus E minus machine. So the physics case for this new collider, this FCC EE at least, the first portion, is not really controversial within our field.
So there's also alternative projects that are on the table. That could do the same or similar measurements, but first, like the Higgs program is really what everybody wants to do for sure, and the FCC could deliver that as well.
Agreed. So for within the field, the physics case is pretty strong, but new colliders, as we were kind of talking about before we began this online, require input from outside. So we're talking about things like funding, political will, workforces, a location is always good. What do you think nations are looking for when they consider funding a machine like the Future Collider? What's in it for a nation like, let's just pick one off the top of our head, Germany? What are they looking for
yes.
when they're funding these projects? What's the big positives for Germany?
So I think in general, it's what is true for all probably industrialized nations, right? Is that they do devote some fraction of their money, of their taxpayers' money, to fundamental research, to just curiosity-driven research, because, well, this is just okay. This is our human endeavor, is to understand the universe, right? How does this all fit together? And of course, particle physics is not the only place, but this is one of the places in the last century that was extremely successful in helping us understand the universe better.
Yeah.
But it's not just that, right? It's not just curiosity, but it's also these kind of very groundbreaking research endeavors. They are so, well, they're typically at the edge of what is doable, right? So you also need technology, right? So it's a driver for technology, and there is always a strong connection between the laboratories and the industry, right? So there's some, of course, you start out building prototypes, but then you need to build for the LHC, for example, thousands of these dipole magnets, right? So there's a feedback to industry, of course,
and this will follow through with FCC, right? Because if it goes ahead, the magnets that are slated for some of the machines, they haven't even been built yet. We don't quite know how to do it yet.
It's more true for the Hadron Collider that is maybe following after the electron-positron collider, because there you need these high field magnets. And of course, this is something that could be very interesting to industry, to have these super high field superconductors. But it's not just on the accelerator side. There's also on the detector side. When we measure particles in these particle collisions, it's not different to when you have some medical imaging technology, right? So this is always high energy photons, then scattering off or passing through tissue, and then you measure how much energy was lost or if the particles were deflected. So there's in that sense there's a lot of technology exchange, but then also on computer science, handling big data, and then in addition, and maybe the most beneficial to society, in addition to the technology feedback, is the people. I mean, it's a big training ground for young people who do their PhD or postdocs, and then leave again and work in industry, right? And what makes people, I don't know what you made study physics. I mean, I was always curious, like how do stars work? How does the universe work? And this is what gets you excited to even start thinking about these complicated things. And then you work on these problems, and then you take these skills that you learn back to your much more mundane problems, right? Designing a new phone, writing software for a self-driving car or whatever. But what gets you started to wanting to learn about these things in the first place is are these big questions about the universe, about science in general.
So we're answering these big questions. We're training a skilled workforce. We're bringing skilled people into the region. We're providing jobs in the local community. There's a lot of positive benefits, not only just curiosity driven, like you said, but also economic feedback mechanisms as well for countries to fund this kind of research.
Yeah, and then maybe because it's not clear to everybody. I mean, CERN is, of course, it's a big lab, right? It has a 2,500 or maybe 3,000 people employed directly, but then really CERN is a service provider, right? It provides the infrastructure, the big colliders to do the research, but actually most of the research is done by universities and institutes all around the world. So there's another 15,000 or so people affiliated via their institutes to CERN and that do the research. So they're not all based at CERN, obviously. They're distributed all over the world. And so you have this, you enable physics institutes around the world to engage in this research, and they're all joining in this big effort.
Yeah, you can't build one of these machines on every university campus. It's just not a viable thing to.
It's really pooling resources I think in a very efficient, very successful way. I mean, the track record of CERN is really tremendous, and I mean, we're also now celebrating 70 years this year, 70 years of CERN. It really shows like how in principle, right, these cross-border international research can work and how it benefits everybody in the end.
Very much so. So before we jump into the German ministry's thoughts on the affordability and the viability of FCCEE, it's probably worth, and you flagged this up before we started, explaining the particle physics priorities of CERN and some of the other nations and groups around the world, because that will help to illuminate the German ministry's position on FCCEE. So what are the current particle physics roadmaps that are being developed by CERN and the US? So you mentioned P5, and this came out just before Christmas in 2023, which is the US roadmap. So do you want to tell us a little bit about kind of set the scene globally, and that will help us to understand the German ministry's position later when we discuss that?
Yes. So yeah, basically all regions have kind of the roadmaps, which then are often community driven, which is very nice, right? You want to bottom up from the scientists what they really want to work on in the next 5, 10, 20 years. And this then, like, there's some community effort often involved, and then what follows is more like the political progress or process. What is actually possible, and so on. So I mean, yeah, and this happens every couple of years. So in Europe, they aim to have this every 5 years. And in the US, I think it's also of the same order of magnitude. And I think in Snowmass, what came out, and well, I wasn't following this so closely, so I was a bit surprised how highly the American community values building, or at least seeing whether a muon collider is possible. I think that would be amazing, but I think there's still a lot of work to be done. That really opens up a very different order of magnitude of colliders. But also they said that for the immediate future, well, not be immediate, but more closer future, a Higgs factory would be very desirable, although they mention explicitly that it's for them it's abroad.
But
right?
they want
so
offshore.
Offshore, exactly. Yes, that's how they called it. Like keep having in mind that, well, there's maybe since many years the people are discussing the possibility of building the International Linear Collider in Japan, which would also be an E+ E- collider, or something like the FCCEE at CERN. Or CLIC at CERN, which was also another project that has been discussed in the past decade as possible follow-up projects. And then, of course, there's other related fields, right? There's the neutrino program. So the US, of course, heavily is investing into DUNE. This is the long baseline neutrino experiment that is being planned. And of course, this is in the US, so this has for them high priority, and of course this is also something that should be realized very soon. And then there's also the electron, what's it called, the E-RIG, the heavy ion collider in Brookhaven, which is on the table.
So I think a couple of things to pull out from the kind of American roadmap is that they've gone with a kind of very diverse program going forward. So they haven't pushed everything into an energy reach machine, for example. They're doing neutrino physics. They're talking about CMB physics. They're really casting the net wide and looking to support this potential E+ E- energy frontier machine, but not necessarily do it themselves. And then
I think,
please.
Maybe just one thing to put in. I mean, I think already in the last 10, 20 years, it has emerged that somehow these kind of big facilities, you only build one of them, but you still want to do all of them, right? So somehow the different regions focus on different things, right? So for example, you have what we often call the intensity frontier, right? Looking for rare processes at lower energy, but very high rates, so you can actually see them, like Bell 2 in Japan. And then, we have the energy frontier, which currently is covered by the LHC at CERN. And then the US kind of focusing a bit more on the neutrino program, which covers kind of like at least the accelerator or particle physics based experiments on the larger scales.
So it's important not to duplicate efforts as much as possible. Yes. Just before we move on from this, China are also in the game as well. Obviously, there's a little bit of tension between some of these Western nations and China, but China potentially pushing to build a similar E+ E- machine, right? The CEPC.
Yes, yes. I think it's, if you look just at the outline or the rough definition of the project, it looks very similar to what is being discussed for the FCC at CERN. So it's a large E+ E- collider, a ring with also maybe the possible option to add a hadron or proton-proton collider afterwards, which covers very much the same physics case, which is basically the Higgs program. And we didn't mention this in the beginning, but of course, if you have a big ring, which is kind of like a repetition or follow-up of the previous lab experiments at CERN, you also have the possibility to run at lower center of mass energy. So you can run with much, much higher luminosity, so much more events you will see than at the lab experiments, but basically repeating the lab experiments. So producing Z and W bosons in very, very large numbers. So you can very precisely measure all the properties of the electroweak sector in the standard model, which might also reveal some surprises. And so this is something that the circular options are very good at, because they have very high intensities. So you have very high event rates, especially at the lower center of mass energies. And then once you push to higher center of mass energies, this is where the ring has the negative consequence that when you bend charged particles on a circular trajectory, you're losing energy each turn via synchrotron radiation. And unfortunately, this energy scales with the fourth power of the energy. So very, very quickly, it becomes just unaffordable in terms of electricity. And you're just irradiating basically your surrounding.
The local farmers,
that's also the reason why, if you think about it, lab, which was housed in the LHC tunnel previously, which is 27 kilometers, right? It went up to something like 210 or 20 giga electron volt in center of mass energy, and just to go up to the 350, we have to go to a 100-kilometer tunnel. So it's it's really diminishing returns here very quickly, which was why many people were thinking about the linear collider option for many years as the more future-proof, or like the only option actually to go to higher energies. And like 350 is kind of what people think is like the highest you can go with a circular collider. And any higher center of mass energy, you would need a linear collider.
So we're gonna need a shift change soon, right? It feels to me like CERN is kind of trying to rerun something they understand how it works, right? So you have LEP, the Large Electron Positron Collider, and then you follow it up with the Large Hadron Collider, the Hadron machine in the same ring. Now you're going to play the same game again. You're going to make a bigger ring. You're going to do your electron positron in there, and then you're going to follow it up with a Hadron Collider again. It feels like, a comfortable pair of jeans. They're just going to kind of rerun it back and go again. So that feels like what they're trying to do now. Whether that will fit in with what the wider community is doing, or whether it will result in duplication of effort, like we're going to talk about, that is one of the concerns of the German ministry. Right. So we've nearly set the table. I think it would only be fair, before we get into these comments, to give some context about Germany's ongoing commitment to CERN, because that is very, very strong, right? Regardless of the comments that we're going to discuss very shortly. They are the biggest contributor to CERN, and I believe you were at these meetings last week. That remains something they want to continue with and potentially give more money, but they need some reassurances first.
Okay. The second statement, I don't think we can make, but okay. At least
potentially.
I think Germany is very much committed to CERN. I mean, it was one of the founding members, and actually like after the Second World War, it was the first international organization where, or one of the first, where Germany was allowed back at the table. So this is historically, I think it's very important. And Germany has always, in the past, strongly supported CERN. And it's really, I mean, you can see this also in the amount of money, right? It's more than 20% of the CERN. More than 20% of the CERN budget is paid by Germany, which of course makes sense. I mean, this goes by GDP of the member states. So this is, of course, justified. And yeah, so in that sense, also the ministry who's directly funding this, they consider this as a German laboratory, right? Or it's a European, but also German laboratory where German physicists can do their research. So strategically, CERN is extremely important for Germany. I think that's fair to say.
Good stuff. Right. So let's get into the meat of this discussion. So this is the slide that's kind of got people jumping a little bit in the particle physics community. So why, given the context that we just outlined and Germany's obvious ongoing commitment to CERN, why is the German Ministry of Education and Research describing the Future Circular Collider project as currently not affordable? What's going on? Why were they saying this at the meeting in Bonn last week?
So maybe to put a bit more history into that. So there's currently ongoing at CERN the so-called feasibility study of the FCC. So this was one of the tasks that was given to CERN in the last European strategy process. So one of the outcomes of that was that CERN should investigate whether a possible Large Hadron Collider actually is feasible of the order of 100 kilometers, where also one could fit an E plus E minus collider before that, right? So I think in this bigger picture, like building such a big tunnel only really pays off if you also do the Hadron Collider afterwards, right? So if we would just wanted to build a Higgs factory, then the other options like the linear colliders at the initial stages, they look in these costing studies, they look like they're a bit cheaper, right?
And I think Patrick Mead mentioned to me that if you wanted to do certain things, you know, like the millions of Z bosons, the tera Z, you could probably do that in the current tunnel with a different machine. So there are different potential strategies for doing this. As you say, you only need the big tunnel if you're then going to go on for the very large hadron collider, essentially the FCCHH.
Yeah, I mean, so of course, everybody has their opinions, right? If somebody would tell me the next project at CERN for like starting in the 40s, right? One has to see it's still 20 years away. And then for another 10, 15 years would be just building another lab in the old lab tunnel and restudying the Z. Me personally, that would not get me
You wouldn't
excited.
be very excited.
I want to learn about the Higgs boson, right? I mean, we've just found it, so we also want to understand it. Okay, but now in this feasibility study, CERN actually did I think this is really amazing how far they pushed it already in terms of like how you could realize such a project in the region, right? So they already talked to all the mayors of all the communes where they would have to buy some land, the neighbors, how you would put the tunnel and the access points such that you have to build the least possible amount of roads. I think they said something like only 14 kilometers of road would need to be built. So they basically moved the ring and placed it so that it's close to already existing highway exits, power lines, all of these things you have to think about. Really fantastic work, I think. And also what's part of this feasibility study, so it's not finalized. So the plan is to have this ready for the actual European strategy update, which is scheduled for early 2026. So 1.5 years still to go, I think. But they have reported a so-called midterm report, and this includes also a cost estimate, which of course comes with uncertainties.
So the ministry is reacting to CERN's midterm report on this feasibility study.
Exactly. So and then you have the numbers, and then there's numbers reported for a so-called baseline option, which is really the bare minimum that you need to do to be able to get to the Higgs program. So that would only need to go to 250 GeV. And then there's the options, okay, if you want to update this to go to 350 GeV, which then allows you to reach the top quark, so to produce a pair of top quarks, which is also very interesting. I mean, the top quark is, probably the least understood and also the heaviest particle in the Standard Model, maybe next to the Higgs, but it's heavier than the Higgs. And of course, new physics might prefer coupling to heavy things. So understanding the top couplings in detail might also be very interesting. But this is only an upgrade option. And then the other option, which is discussed, is that the baseline has 2 interaction points, and a circular collider is very nice that you can basically, with the same particles, you can make them collide in multiple places. But also means you have to have the interaction regions, which requires some specific focusing magnets in these interaction points.
Huge detectors in those interaction points.
So the detectors, so that's important. In all these costs, it's only talking about the accelerator and the infrastructure around. Experiments are always funded separately. So, and that's which also where other countries join in. So, for example, the US, which is not a CERN member state, they don't pay a membership fee to CERN, but they are part of the experiments. So they pay part of the experiments, but probably not part of the accelerators. I mean, for the LHC, they have provided,
because they're paying for Fermilab and their own accelerating complexes.
But actually, I mean, okay, which was very bad for the US, the death of the SCC, but that allowed the US to contribute to the LHC. So they actually sent or built part of the magnets of the LHC, which is a significant part of the cost of the building cost of the LHC. So they did actually contribute to the accelerator projects, although not being part of the CERN member states. And so, okay, so then the ministry took these numbers and they took them serious. And said, okay, this is your best guess. And they added them up, and then they looked and said, okay, this does not fit into the running CERN budget, which is, of course. So
this is the contribution that Germany currently gives, I guess. Corrected for inflation up to the 2040.
I think all of these costing plans, of course, there's always uncertainties, but you do them in some units, for example, current euros or current Swiss francs. And then, of course, this runs with inflation, assuming that the contributions also scale with inflation, which actually is automatic. So this is actually one of the great things at CERN, is that the CERN budget in the contract, in the international contract, which is not so easy to change, has an automatic correction for inflation. This is actually good. They don't have to go every time and renegotiate. Very smart people who wrote these contracts 70 years ago.
Locked people in, good.
So this at least allows some planning security. And this is, one shouldn't underestimate. I mean, that the CERN has such a big budget that allows significant, like projects of significant scale to be paid off the running budget is, of course, fantastic, because you're not bound to national budgets, to national politics, which really allows planning of scientific projects over many decades. I mean, you need this for these big infrastructure projects, but since you don't have to negotiate for this every time, you have some leverage there. But as it turns out, these projects become bigger and bigger, and this doesn't look like it fits into the running budget. And this is, of course, a problem, because that means somebody will have to pay the difference. And I think this is the key message here, is that with this plan on the table, and no additional funding being secured yet, it means it's not feasible. With these two conditions in mind, right? That this is an estimated cost, and this is what we know what is guaranteed funding.
So when people are looking at this slide and getting really desperately concerned and thinking, oh, they're not going to support, essentially what is being said is, within the kind of current contract that we have, that the numbers just don't add up. So we have to say it's unaffordable. It's not affordable at the current time, because without adding extra money in, that's just a statement of fact.
So I mean, in that sense, I mean, the ministry they're not making the politics, right? The
And they
ministry
can't,
is
I guess they can't go outside the current contract, right? They can't start saying, oh, well, we really like it and maybe we will.
so
They'd have to go back to government to ask for these additional funds, right? You can't just go off
exactly.
piste and say what you like.
Of course, if I don't know, if Chancellor Scholz, Macron, Sunak in the UK, right? They get together and
not for much longer, I
conference,
don't think, but yes,
and make a press conference and say we're going to build this. That's a very different thing. I mean, this is like, of course, this is. I'm not saying that this is happening, and I'm not. But the current budget is agreed upon, and this is like also within the ministry, right? They have a budget. This is like the parliament gives a certain budget to the science ministry, and also gives certain tasks. And there's no room to like, oh, let's just add another 100 million per year or something like this. It's not as easy as that.
And you mentioned as well, some of the costs aren't even in there yet. So costs for detectors, who's paying for these? Costs for various other things, staff running costs, these sort of things.
I think you had it on the previous slide. If the contribution,
we can slide around
here, right? So you see, so the standard CERN budget every year the German is paying is 270 million, right, currently, and but there's additional costs. So there's like these what is there listed as CERN experiments. This is what the ministry pays over these 3-year periods to the universities in Germany that contribute to Atlas, CMS, LHCb, and ALICE. So this helps the German university groups to participate in this experiment. So this is only running and exploiting the experiment, doing physics, right? Doing the physics analysis and so on. And then there's another budget which is it's only for a certain period, which is paying for the big upgrades of the Atlas and CMS detectors. So this is 130 million stretch over 14 years. So and this is it's a different order of magnitude than building an accelerator. Detectors, they cost several hundred millions in total, just counting material cost, but not billions. So this is but still it's money, very significant amount of money, and that has to be paid as well.
And I think they mention explicitly, if we go down into the slides, the operational cost, the cost for the experiments are not even included in the current plan. So there's these uncertainties as well. You could get into a situation where costs start spiraling and they're far higher than the initial assessment. There needs to be a better steer from CERN as to what these costs could potentially be to give these nations an idea of what they're signing up to, essentially.
Yeah, and actually, I mean, if you look at this slide, I mean, to me, actually, the most scary number is the operational cost of 1.3 billion per year. So if you look at what is the annual budget of CERN, it's below that number. So, it looks very ambitious, and of course, I mean, we have a great physics case, but we have to go out as a community and convince the politicians, the society, other science fields, that this is a worthy investment. I mean, it's not a no-brainer, and it needs real work, and it needs to convince other people, the other players in this game, that this deserves additional funding.
And this number you point at, I guess this is also difficult in a world where people are talking about carbon emissions and the cost of energy as well. If you're going to say, why do we need this? This is going to pump out a hell of a lot of CO2. You have to be kind of on top of that as well. You can't be committing money to that. It looks bad if you, as we're going to talk later down the road, particularly if it just ends up being a repeat of a machine that is being done in China or something like that.
And I think so. There is, I mean, it will use a lot of electricity, but of course, on the other hand, we have to convert society to a carbon-free society anyway. So my hope would be that in the 2040s, we don't discuss carbon emissions from electricity anymore. Of course, it means we have to build more photovoltaics, wind turbines, and nuclear power plants to have low carbon emission electricity available. But that part hopefully is more or less emission free. What really will cause CO2 emissions is the concrete needed for the tunnels. Yeah. And this is significant. And CERN does take this very serious, right? Yeah. So in this study, they discuss environmental impact very much. There's plans or ideas, at least, what you can do, for example, with all the molasses that you excavate from the tunnel. Yeah, because this is in principle useless soil. You would have to put this basically to the side, but there's ideas how you can make this useful soil that you can use it in agriculture again, and so on. So these kind of things are being thought about, and also how you can make lower emission concrete and so on. It will not be zero, but one has to get it to
a minimal level.
To get to a minimal level that one can say, we as a human society, right, once per world, we want to afford such a project also for its environmental impact. I mean, this has to be offset with some other measures somewhere else. And the individual numbers, they always look big, but also one has to see, okay, this is one project. It runs over many decades. It does unique research and will deepen our understanding of the universe, hopefully.
Yeah, and you have to sell that story. One of the things that the ministry very much pointed to, and I can I can definitely understand the logic of this, is you're presented with this machine that you have to pay for, and your initial reaction is, why should we pay for everything? It seems like other nations haven't necessarily agreed to increase their contributions towards CERN, and I guess Germany doesn't feel like it needs to be the first to show their cards, right, and do that. If they say, oh yeah, we'll do this, then other nations are going to kind of sit back and enjoy the physics while paying less money. So
yeah, I mean, so yeah, maybe another background that's important to know is so how is CERN actually governed, right? So there's actually the CERN laboratory and the CERN management that runs the laboratory, and then there's the so-called CERN Council. This is the political body that kind of runs or oversees CERN activities, and in there's representatives from all the member states, and they get to vote on all the decisions. And well, it's one country, one vote. Yeah, so of course that gives more weight to the smaller countries that pay less of the share.
Yeah.
It has a subsection, the financial, what is it called? The financial committee or so, which has to decide on all the financial matters.
Right.
In that, votes are weighted by share. So they are the big players.
So the big boys, Germany and France and
Germany,
UK
France, UK together basically make up 50% or so of the vote. So you have to convince them that things are happening, and so on all financial matters they have to agree in the end. And yes, I mean, surely these things are being discussed in the CERN Council. This is really the place where CERN proposes their funding plans for the next year, and then the member states have to sign off on it. And I think these are tough negotiations, right? Because as everywhere in politics, people don't freely say, "Oh, we spent more money."
Of course. Why they're not going to say, "Oh, okay, that's how much it costs, is it?" Yeah, okay, yeah, we'll pay all of that. You're gonna negotiate and say, "Well, I want to. Can you get me 5% off on this, or can we do it a different way and make it slightly cheaper?"
So I think what would be nice, and I think that's like what probably Germany or the ministry in Germany is looking for, if like the two countries that benefit the most of CERN, which is the host states, it's Switzerland and France, if they would do the first step, I think that would be extremely helpful in all of these discussions. And of course, there was the visit of President Macron and at the time Swiss President Berset. They met at CERN fall of, when was it? 2022? No. I think it was last year. No, I think it was last year, 23. And I mean, they took some nice pictures, but of course, you can interpret this in many ways. But there's no official statement or anything about this.
So is your sense then that people getting really worried that, this project is never going to get off the ground because Germany's not interested, quote unquote. It's really just.
I think this is not what the statement is.
It's more about clarity and making sure that those financial plans from all stakeholders are in place.
The German ministry actually understands the physics case very well, and the German community also wants to embark on this Higgs factory journey. Of course, historically, because there was a lot of studies and expertise for a project that was foreseen. There was a project proposed at the end of the 90s to be built at DESY in Hamburg. That's a German particle physics lab called Tesla, which in hindsight would have been the perfect project, right? It was a 250 GeV linear collider. Would have found the Higgs. Of course, you don't know this beforehand. It would have been beautiful.
I know you were a big ILC guy as well, so
so this just historically, the German community was very much focused on the linear collider, having in mind that if you want to go to higher collision energies, it has to be a linear collider anyway. So it gives you more option in the energy frontier direction, while the circular option gives you the option to redo the Z and W physics in extreme precision. And both are valid things you want to look at. But the core thing, which is the Higgs program, both facilities can do. And this is just how things developed over the last 10, 15 years. There was the ILC project, or maybe it's still as an option in Japan, and Germany was always looking to support that, at least the German physics community. But now we're discussing what comes for CERN as a next project. And I think, and this is also clear to the German ministry, it is extremely important for CERN as such a big lab, right, to justify its existence, its big budget. There has to be some flagship project at CERN. But then, if you see how big these numbers are, CERN does not just do LHC, right? There's also a wide range of low energy fixed target experiments at CERN. There's a big
antimatter factories. You've got SHIP and things coming online now. The forward facilities,
exactly,
all these kind of things.
And this is important for the field to have this complementarity, right? To have the big flagship projects that attract attention in the public. And it really allows us to explore the energy frontier, things that you can only ever do there, but it also then facilitates, allows that we have all of these beam lines and the smaller accelerators that then provide beam to these fixed target experiments and so on. And so my hope would be that for whatever next project is, that there's also enough money left at CERN that we can do a non-collider program, right? It's really important for the field to also do these smaller scale experiments.
Definitely, and we're going to talk about that, about the kind of tunnel vision, as they mentioned in these slides in a little bit. You flagged up when we were discussing this on Twitter, the FAIR facility. Does Germany also have a lot of commitment elsewhere in terms of funding? So they really need to be careful about what they are able to fund.
So that, of course, there's of course, as the US and other big countries, they don't put everything into a single project, evidently. And Germany has, of course, other big science projects, even other big collider projects in Germany, right? So there's the FAIR project, which is basically a facility to study heavy ions. So that's, of course, more nuclear physics, not particle physics, strictly speaking. But from the ministry point of view, this is fundamental understanding physics on the fundamental scales. So this comes kind of out of the same budget, and this is mostly actually funded by Germany. So this is and it costs several billions. So this is a very significant project. There's another big project coming up, which is very important for DESY, which is Petra 4. So this is a new light source. So this is really, it's not for fundamental research, but it's for applied physics.
But so it'd be like Diamond Light in the UK or something like that.
It's a multi-billion-dollar project that primarily Germany is funding. And then they have the XFAL running, of course, that's very successful as a free electron laser at DESY. And so there are multiple projects that all have to be supported somehow. So it's a bit naive to think that everything can and will go to CERN in the future.
So you have to have very, very clear budgets, very, very clear ideas of uncertainties, because there are a lot of other projects which are depending on these similar budgets. Very quick comment. Do you think there's any political game playing with the Director General ship being up? We're not paying. Hint, hint. Maybe we can get the DG.
I don't know.
Speculation. Pure speculation. No. Let's jump across.
I think I have really zero idea who Germany would support as a next.
This is my tinfoil hat on, so
Yes.
To be clear.
I think since before Fabiola Gianotti, Rolf Heuer was Director General, who was German. So I think it's very unlikely that there is a German candidate. I think it will not happen, and I don't know how these nominations play out. I'm sure there is negotiations behind the scenes who gets this very important role, but I think this is also to be seen in a broader picture. Who gets which role in which international organization? I'm sure there's some politics being played.
I'm on the.
All I can say is that Mark is a great guy.
I'm on the vote, Mark. Because he's a linear collider guy. Yeah, I know. And
I worked with him. He's fantastic.
He was my old third and fourth year lecturer in Cambridge. So vote Mark. That's all I'll say. So where are we up to? So yes. So if we kind of summarize that kind of. The death slide that people are really, really worrying about, this slide up at the top. So it's not something where you should be, desperately concerned, but it's a call to put the house in order rather than a lack of interest, right? I think Patrick Koppenberg mentioned to me that Germany had a similar stance historically for the Large Hadron Collider, and Martin Bauer was saying they kind of were worried because of the costs of reunification in Germany at the time of the LHC that similar concerns were raised about the planning and development of the Large Hadron Collider, and we have it today. So we're probably just seeing the normal politics play out, right? Is that fair?
Yeah, of course. I think that this is when you're talking billions. I think people
set up and take notice.
And I think so. This was way before my time, of course. But so the stories that I heard is that when the LHC was approved, it was actually a downscaled version of what it actually became later on. And it was only possible to fill up the ring with all the magnets and going up to the energy that we now have. Because the US could join in. This played really in favor of the LHC. But if I remember correctly, I think the LHC project, the CERN contribution, this was really paid out of the CERN budget. Of course, stretching it over a long time. So basically, CERN took big credits, and they also had to juggle a bit with their salary payments or retirement payments. So they basically made people buy holiday days for reducing their salaries and so on, and but that allowed them to take it out of the current or the running budget. And I think this people have to remember this kind of situation, that you have to make
some sacrifices to get these things off the ground.
To get it off the ground, and then maybe there's other money appearing later, or people say, okay, this is a successful project and it's not running over cost. Then we can commit to more.
When we have the thing now, everyone remembers the kind of folk history, right? That it was all perfect and easy, and we went.
In hindsight, it's fantastic, right? But of course, when you start these projects, there's a lot of uncertainty always.
One thing that the ministry flagged up, which they were particularly concerned about, was the funneling of huge amounts of money into the FCCEE project, which could be a little bit of tunnel vision and leave CERN with not a lot of flexibility. So they particularly highlighted, and we've touched on it, the possibility that China is considering building one of these E plus E minus machines. What is the concern here for the ministry? What are they concerned about here?
So I mean, of course, in some sense, it's a bit orthogonal, right? Because I mean, China, if they for themselves decide, okay, we're going to fund this big project, that's of course great, right? From a physics point of view, as we've discussed, it can cover more or less the same physics case, so that's great. But of course, if you think about it strategically, right, from the lab perspective at CERN is committed to finishing the LHC and the high luminosity LHC program, which takes us already to the early 2040s. So before that, because just running the high luminosity LHC takes so much of the CERN budget that just ramping up a second project in parallel,
it's just not possible.
Doesn't seem feasible. Right? This is really not credible, and that means there is some time still that will pass before this project becomes reality. Now, if China decides in the next 5-year plan very soon that they're going to build this project, and maybe they start building around 2030 or so,
then CERN is way behind the Chinese project.
Then the question is, do you want to build something that is very similar just 10 years later? And of course, the danger is that what physics we're going to do at this machine is becoming irrelevant. Or it's
becoming a cross check of what's going on in China.
And of course, with such big projects, of course, cross checks are always important in physics. But of course,
But if you're spending that amount of money, you kind of want a flagship, unique project, right?
Absolutely. I mean, this is bringing us to the strategic view, right? I mean, CERN is a European lab, and I think the European countries as a whole, they have the ambition at least to stay ahead of the science game, right? And so that means you want to do a groundbreaking science at CERN. This is the big lab in Europe, and you want to have something that is actually relevant.
But China could eat your lunch in the 15 years before you get started.
Yes. I mean, I think one shouldn't bet on that China doesn't manage to, like, if they commit to the project, that they will then somehow not manage to do it.
They can probably do it quicker. Well, they can definitely do it quicker because of the lag that you've talked about, and probably more cheaply as well if they're,
I mean, of course, the big advantage of CERN is that we have, it's a running lab, right? It has all the infrastructure already in place.
True.
Of course, one has to add a lot of additional infrastructure to have this 100-kilometer tunnel and the new access points and all of that. But you have the expertise, the people, and also office buildings and all the other infrastructure, the pre-accelerators that you need. That is, of course, a big pro for CERN. But I think, and I do agree with the statement that was made by the ministry, is that you have to have also a credible plan B. Because other things like either at the end of this feasibility study, the cost looks even less favorable. Who knows? Maybe it looks better. I don't know. But maybe it looks.
But then,
less
if the
favorable.
physics case has gone down from unique to cross-check as well, then that's
that's and I mean the time scale. CERN will have a hard time to be faster, because as we said, they have a running project that, of course, will deliver great physics for another 15 years or so after the upgrade. But one has to stay relevant also for Europe, for the science environment landscape in Europe. And of course, I think there are other options on the table, right? I mean, there's surely the possibility to also to consider a linear collider, for example, at CERN, or a muon collider at CERN, which would bring us to the very high energy frontier. Or at least the linear collider could complement a circular E plus E minus collider because one thing that the circular E plus E minus collider cannot measure, at least not measure directly, is the double Higgs production, which then gives us access to the trilinear Higgs
the
coupling,
Higgs potential measurement.
Exactly. This is really really the holy grail of Higgs physics, is to measure and map out the Higgs potential itself. And of course, there are possibilities to constrain this indirectly, but having the direct measurement of two Higgs production processes, maybe we get at least part of the answer from the high luminosity LHC already, but a linear collider with something like a 1 TeV center of mass energy will be probably the best experiment to exploit this. Well, maybe until we have a muon collider. And the other thing, which is also, now we're getting a bit into the details, which is helpful complementarity for the Higgs program, is that there's the dominant process to produce Higgs bosons at the plus minus is the so-called Higgs Strahlungs process. So you produce the Higgs boson in association with a Z boson, and so that gives you that's why you need 90 plus 125 GeV center of mass energy plus a little bit to be over the threshold. But there's a second process which picks up at higher center of mass energy. It's called the WW fusion process. And measuring that, in addition, is an important ingredient to get the total width of the Higgs boson out. And so having something that collides at higher center of mass energy, in addition to this, to the circular collider, could complement this. So now, of course, now I'm just speculating, but just saying that there's other options that could be relevant and could be an interesting.
Could allow you to have that uniqueness at CERN and keep it as a working cutting edge laboratory. And I think the thing that this slide again at the end really kind of rattled particularly our US friends was that I think the German ministry is concerned that if you commit to this project, you start doing it, and then China starts, building theirs 15 years earlier, you end up starting to dig these tunnels at CERN, and then you realize the physics case has diminished, and you end up with another superconducting super collider, another SSC with some tunnels built and then abandoned because we don't really see the need for it anymore. And that would be an absolute disaster and just a complete waste of money and horrible imagery for the field.
I agree, and it would also be a disaster for CERN, right? Because that's one gambles away kind of the great potential that the lab has, right? It's really such a unique setup where you have these 23 member states getting together and funding in a very robust way fundamental research, and so you must invest this into something that really pays off in the end.
So if this is a case, this presentation isn't all doom and gloom like some people have been saying, and it's more rather a cautionary tale and a call to get the kind of house in order and have contingencies. What does CERN need to do if they are committed to this FCC EE project? What do they need to do to make this a reality? Let's say China doesn't go ahead. What do they need to do now to convince the German ministry and other funders that this is the way to go?
Well, of course, and I'm sure this is happening, right? There must be already the discussions with the funding agencies, but of course, before any of these discussions are finalized, no funding agency will stay a step ahead and say, "Oh, yeah, we're going to pay that," right? So I'm sure there's negotiations being had between. I think the host states, they surely have an important role to play here. But also the big contributors, so UK and Germany in addition. It has to be between them that they see whether this is financially feasible or not. I think CERN can also work, or we as a community can help spreading the word about the importance of the physics case. I think
this is a long video I really want to do, and I want to talk to yourself and a few others, and I'm gonna make a big list of the bullet points and stuff on this, because I think people are really struggling to understand what I see. A lot of people, particularly in the influencer space, they're like, oh, they're still looking for dark matter, and it's like, that's not really the use case. The use case is the Higgs
I think
physics.
One has to. I really like to compare our situation now, like building any plus minus collider that will map out very precisely the Higgs sector. This is very similar to the lab experiment or the lab collider, because at lab, nothing was discovered. No new particle was discovered, but we very precisely mapped out the electroweak part of the standard model, which allowed us to precisely predict where the Higgs would be if there's a Higgs boson, or
and this is what we're planning essentially to do again. So
yes,
right, okay,
although we have what's a bit less fortunate now for us is that we don't have this very clear missing piece of the puzzle. Like the Higgs boson was such an obvious missing piece in the self-consistency of the standard model that either we break it if there's no Higgs boson, or we find the Higgs boson. So we found something that's consistent with the Higgs boson, and now but
we're still at a situation where we haven't found any obvious signs of new physics, so we need to go and look in far more detail to know where to go next.
But we have so many open questions, right? We don't understand dark matter. We don't, whatever makes galaxies rotate differently than naively expected from Einstein's equation. We don't understand the matter-antimatter symmetry in the universe, right? Why do we only see matter but not antimatter in the same degree? All our formulas predict basically similar or the same amount, and we don't understand this. And there's more questions. Why are there 3 generations and all of these? And of course, we don't know for sure, but now we have this new particle, and it couples to every other massive particle in the standard model. And it's I think it's very naive to assume, or simplistic to assume, it will just be the simple most Higgs model that we can write down, which is what we have now. Because you have so many parameters that are just numbers that fall from the sky in the standard model. And we don't know if there's any structure behind them, right? And if you start measuring out all the different couplings, and people say, oh, maybe this is like, why would you just measure these couplings more precisely? No, this is our only way how we have access to understanding the universe. This is the observables. And of course, behind that is the model, right? And it's basically, you measure all these numbers, and then you have to see whether you find some underlying pattern that explains this. And of course, the most interesting one would be if we see deviations from what the prediction of the standard model will be. And I think this is really important that we make this case. And all around the world, in Germany, but also in the UK, in recent months, whenever CERN came out with this press statement about this 100-kilometer tunnel, there were opinion articles saying, again, they want to build a big collider. Why do we need this? And I think this is our job to explain this.
And I think they captured like Fabiola at like some drinks reception, and she was like, maybe we find dark matter or something. And then it goes all around the world, and then people just think, oh, they don't really know what they're doing. We need to make that case, like you said.
Yeah, I mean, and we have guaranteed results, which is the precise understanding of the Higgs sector, and direct discovery of dark matter. So would be the cherry on the cake, right? It's not why we built this in the first place. We have a very good physics case understanding the Higgs boson, but also the top quark. I mentioned this before. This is also not as well understood as one would hope. And I think, just saying, okay, we've understood things to the few percent, 5-10% precision level, and just call it a day is, as a scientist, very unsatisfactory. Right?
Yeah, it would be insane to stop at this level. Like, why are we even doing this if we found this thing and then we're just going to go, oh, okay, we found it now. Like, that'll do.
Yeah,
it just seems mad.
Basically, you can think of it as like you have a blurry picture, and it looks kind of what you expect from the simple most model. But you should look.
Of course,
you should have the sharp picture, and then you can more confidently say, oh, it's really just the standard model, or there's something more interesting.
Agreed. So CERN needs to be talking to those funding agencies and partners behind the snes. They need to get
and
that,
the public.
And getting that message out about the physics case to the public. Yeah, definitely. Because without taking those people with you, you're going to be in a complete mess. So if they want to realize that project, that's what they need to do, and they need to make these contingencies. I guess understand what China is doing. I don't know when we'll get any clarity on that. If there's any Chinese roadmap on that, do you know any details?
I think that, I mean, there's a new 5-year plan coming up, but that will not be a decision, right? There might be a statement in there which might be on the same level as what we know from SNOMES and European strategy documents, which might say, okay, we have the ambition to do such a project, which is not yet a project approval, right? Yeah. So I think that maybe within 2 years, 3 years, we will not have a firm answer yet from China. Yeah. So we have to work with this uncertainty. And nevertheless, I think CERN as a lab also must have, like as a world-leading particle physics lab, should have the ambition to not necessarily have their plans dictated by other players. They should confidently propose their own project. Nevertheless, I think it's important to have a good plan B, because in the end, you cannot necessarily influence what other countries do in the world.
And you mentioned that plan B, and this is, like we said, came up in the in the ministry's presentation, and they suggested that CERN should look at contingencies if the FCCE does not go ahead. So you've kind of teed this up very nicely with discussions of ILC and things like this. What could CERN potentially look like without the FCC? Are we talking about a linear collider? Are we talking about more forward facilities? Are we talking about working on plasma, working towards a muon collider? Are these all options? What would you suspect CERN would look like if we weren't to go ahead with the FCC?
Yeah, so there are things like developments in the pipeline for having more efficient particle colliders in the future. We are not there yet, right, with these plasma accelerators. That would be fantastic, but I think that the real challenge there is to get enough luminosity, so to get the collision rate to something that is relevant. And like you have a high energy, but okay, if you don't have the number of collisions, you will not do interesting physics with this, unfortunately. But a lot of things can happen within a few decades, right? Mm-hmm. I think one has to be open to such developments. Also, muon collider might have. I think they are already made good progress over the last 10 years in the feasibility of the project.
The 10 years ago, and things like this, high luminosity, muon.
There's a lot of technical things that are now much better understood, that people really believe that is something that could at least be done in the future. There's still a lot of work to be done. And I think, CERN could be in there as well. But of course, the US is now also putting this as a higher priority. And of course, I'm sure the US community would also like to see this being realized at Fermilab or somewhere in the US. But yes, I think for me, always the biggest problem with the FCC project was like the big motivation to build this big tunnel, as we discussed earlier, is to build a hadron collider in the future. But you basically tie yourself up to this project, to this specific plan for really the next 70 years or so. It's really a big commitment to a very specific direction. Other projects that are possible, like linear colliders or so, they have a bit more flexibility in the sense that you can build a baseline version, which is 15 kilometers long and fits just enough accelerating structures so that you get to the Higgs production threshold. So you can study the Higgs program, and then you can extend it, and you can build higher center of mass energies, or you make advances in plasma acceleration, and you can replace your acceleration cavities with something else.
Is there a possibility, Christian, maybe this is a naive question, that if China came online with the CEPC, maybe you dig the tunnel and you just go straight to FCCHH? Is that not something that you would?
No, I think this is certainly a possibility. Okay. I mean, now we're really in speculation territory.
Of course, yeah.
But there, I think, and this is really still up to R&D, is whether these high field magnets, so we're talking 16 Tesla dipole magnets, can even be built. And okay, this would be a very great spin-off for industry if such high field superconducting magnets can be built. But it's not clear. This is still has to be done. A lot of R&D in this direction.
So there's a lot of possibilities, but they really need to nail down
Yeah.
What are we going to do if certain things happen?
So I think the time scale is important in the sense that for CERN as a lab, but also for the high energy particle physics community, to have something on the horizon that comes after the high Lumi LHC program, because these projects take such a long time to be realized. Yeah, so that kind of puts a bit of pressure on CERN or on the community to make a decision within this decade, let's say, right? So that one can do the preparations that are necessary to build such a new facility in the 2040s. So that means we don't have to make the decision tomorrow, but we also don't have infinite time to think about other options, right? So I think until when this decision will be made via the member states or the CERN Council or whatever, one has to do the homework and prepare the different options, in my opinion, to be able to react on other developments that are happening. Yeah.
And I think that's only fair, right? Nobody is going to want to fund anything in any field of business or any large project unless you have clear strategies and clear contingencies for changes. This is just a normal thing. And I think that's a really nice segue to my last question. So let's wrap this up, Christian. People have been getting very bent out of shape, very concerned, very worried about these statements from the German ministry. So can you reassure them? What was this presentation about? Was it all doom and gloom, or was it really just,
No, I mean, I think it really it puts realism or reality into this discussion. Yeah. I think we as a community, we have to understand that this is it is a very expensive project. Yeah, and that means we also have to work harder to motivate the need for this project. Yeah. And also convince everybody involved that this is also the best project that we can come up with to do the physics that we want to do. And I think that's on us, and I think it's in the right of the ministry or any funding agency to ask these questions and basically say, okay, we are supporting CERN. I think they made this very clear. They are supporting CERN. They also understand the physics case that we're making, but they also say it has to somehow fit together with what is financially possible.
I very much get the sense, Christian, that people who were not in the meeting and didn't hear kind of the whole context and saw slides like this, they got very concerned and confused and worried.
Yes.
And then people like yourself, people like Martin, people like Freya, who were actually in the meeting or tuned into the meeting, heard something very different, which was, we have a great support for this project, but you really need to kind of, dot your I's and cross your T's, and then before we can get on board.
It's also, I mean, of course, this is not the first time these things were discussed, right? Yeah. I mean, of course, we actually have, I must say, we have a very
CERN Council in February or something, I think these.
Well, okay, I mean, these things are not public, but at least in the German community, we have a very good relation with the ministry and the relevant section within the ministry that is funding our research. Is that like we have these community meetings every year where we discuss the current status and so on, and there's always a representative from the ministry, and they're also always very openly, they say, okay, we want to support you, but this is also, there's budget realities, right? Yeah. And so I think
this is something we're not necessarily very good with, and you had a very nice phrase before we started this discussion, which was, in the field, we always think we're doing the greatest thing. It's the most important. It's the best physics. Why would you not want to fund it? But there are realities there.